Hi friends, let us continue our topic of the numerical methods. The earlier two methods were the methods of solving an algebraic equations or transcendental equations. Now, we are switching from linear or transcendental equations to the system of equations, more than one equations. Precisely the linear system of first degree, linear system of equations. So these three equations, 10x minus 5y minus 2z equal to 3, 4x minus 10y plus 3z equal to minus 3, and x plus 6y plus 10z equal to again minus 3. This is equation number 1. Equation number 1. Equation number 2. Equation number 3. So solving such linear system of equations, we are going to discuss three different methods. How many methods? Three methods. Number 1 is Gauss-Seidel method. This one. Second method is the Gauss method. And third method is the relaxation method. These are the three methods. So let us begin with the Gauss-Seidel method. So this Gauss-Seidel method, Gauss-Jacobi method, Gauss, both the methods, they are called as an iterative methods, repetitive methods. These methods are precisely devised or made for some special system of equations. There is some special in these three equations. If you observe this closely, there is a peculiarity, some characteristic of this equation. What is this equation? This system of equations is diagonally dominant. What does it mean? What are the diagonal elements of this system? There are three equations. There are three unknowns. From these three equations, we want to determine the values of x, y, and z. Okay. Specifically, this system is diagonally dominant. Why? Because along the diagonal, the coefficients are 10, 10, 10. It may be plus or minus. Or absolute value of the coefficients of the diagonal elements is maximum. The system is said to be diagonally dominant if and only if mod of A1, this element 10, is greater than mod of say second element B1 plus C1. 5 plus 2 is 7. So 10 is greater than 7. See the first equation. This 10 is greater than 5 plus 2. The first element, first diagonal element. Second diagonal element is this minus 10. Again its absolute value is 10. Again 4 plus 3 it is 7. So 10 is again greater than 7. The third diagonal element is again 10z. 1 plus 6 is 7. Again 10 is greater than 7. So such system of equations, they are referred to as the diagonal dominant element. Okay. So this method is specially devised for such diagonal dominant system of equations. So what is the method? Step 1. You number the equation. From these equations, find the value of x, y and z. From 1, let me write down, don't have space. What is value of x? Therefore, from equation 1, it is equal to 3 or 1 by 10 times 3 plus 5y plus 2z. After rearrangement, 10x is equal to 3 plus 5y plus 2z. Therefore, x is equal to 1 by 10 times 3 plus 5y plus 2z. From second equation, what is value of y? It is again 1 by 10 times 1 by 10 times 3 plus 4x plus 3z plus 3z. And from third equation, what is the value of z? It is again 1 by 10 times minus 3 minus x minus 6y. So throughout our calculations during the process, we are using these three equations for calculating x, y and z iteratively, repeatedly. First of all, we assume that the y equal to 0 and z is equal to 0. This is the step 1. After this, we assume y equal to 0 and z is equal to 0. Therefore, from equation 1, put y equal to 0, z equal to 0 in the equation 1. So 0 plus 0, it is 3 by 10 simply, x. Now this value is the first iterated value of x. It is 3 by 10. It is 0.3 of course. So from first equation, with the help of values of y and z, we determine the value of x. Now we shall use the second equation. Second equation gives me the value of y with the help of x and z. I need the values of x and z. So, put again, we put z is equal to 0 and x is equal to this value. X is equal to. Throughout this process, we would be using the most recent values of all x as well as y as well as z. The value of x, recent value of x is 0.3 in equation 2. Therefore, y1 is equal to 1 by 10 times 3 plus 4 times 0.3. This x is we have assumed as 0.3 plus 3 into 0. We are assumed z is equal to 0 and x is this. These values I have calculated. The y1 value is 0.42. So from the first equation, I have put y equal to 0, z equal to 0. In the second equation, let me call these equations as Roman 1, Roman 2 and Roman 3. Okay. From equation Roman 1, this is from equation Roman 2. From equation, third equation, the first iterated value of z1 is equal to again 1 by 10 times. The formula is minus 3 minus x, recent value of x is 0.3 minus 6y, recent value of y is 0.42. So these are the x1, y1 and z1. This set is 0.3, x value of x is 0.3, 0.42 and the value of z is minus 0.582 minus 5820 minus 0.582. So this is first iteration. First iteration. We are repeating this procedure 4 times up to 4th iteration. This is the first iteration. We are repeating the same procedure exactly. Now this is the first set of values of x, y, z. I have denoted them as x1, y1 and z1. Now second set x2 from this above equation, Roman 1. The second iterated value of x is 1 by 10 times 3 plus 5. Most recent value of y is this 0.42 plus 2z 2 times minus 0.582. This gives me second iterated value of x, x2 as 0.3936. y2 as from equation 2. This second equation. It is 1 by 10 times. See this. Formula is 3 plus 4x. What is the recent value of x? It is not 0.3. Note this. It is not 0.3000. Perhaps it is a recent value. So it is 4 times 0.3936 plus 3z. Z की recent value यही है minus 0.582 and this is 0.28284. Second iterated value of z is found from the last and third equation. It is 1 by 10 times minus 3 minus x, most recent value of x, minus 0.3936 minus 6y, recent value of y, y2, 28284. So that comes out as minus 0.509064. So, second iteration. Has given me this set of values. Value of x is 0.3936, 0.28284, this should be negative, minus 0.509064. Now, third iteration from equation 1 again. We are using this 3 equation throughout. The third iterated value of x, formula is 1 by 10 times 3 plus 5y, recent value of y is 0.28284 plus 2z, recent value of z minus 0.509064 over. So third iterated value of x is 0.3396072. From equation 2 now, The third iterated value of y is 1 by 10 times. 3 plus 4x plus 3z. 3 plus 4 times this value of x, recent value of x, just we have determined. 0.3396072 plus 2z. Recent value of z is this, minus 0.509064. So y3 comes out as our iterative value. 0.28312368. 0.281238. Z3 from equation 3. Z3 is 1 by 10 times. Minus 3 minus x. X value. Recent x value is this. 0.339672 minus 6y. Recent value of y, just we have determined. 0.2812368. Calculate on calculators. The third iterated value of y is minus 0.50383494. So this is the third state, third iteration. What values have we got? Minus 0.33967072. Value of y is 0.281238 and minus 0.50384498. The fourth iteration is I have calculated it is x4 value is 0.3396072. Value of y4 2831238 and value of y minus 0.503844 928. And fifth iteration, I have calculated it as, this is now comes out 0.34079 485 0.285167 64. Sorry, and z value is minus 0.5051796. So the last iterated value, this x5, this is x5, y5 and z5. So from 4 and 5 we see that value of x is 0.34. We consider only first two digits, 0.28 and minus 0.50. This is the answer. Value of x, value of y and value of z. You can put these values 0.34, 0.28 and minus 0.50. To put these values in this equation, it will approximately near to the solution of this equation. It will satisfy this equation approximately. So that is how we solve the examples of solution to the linear system of equations by making use of iterative method of Gauss-Seidel. Thank you very much. Thank you. Now, two examples for homework. Solve 83x plus 11y minus 4z is equal to 95. Second, 7x plus 52y plus 13z equal to 104. Third equation, 3x plus 8y plus 29z equal to 71. Gauss-Seidel method. One more example. (20x) example number 1, 2. 28x plus 4y minus z is equal to 32. X plus 3y plus 10z, x plus 3y plus 10z equal to 24. 2x plus 17y plus 4z is equal to 35 by Gauss-Seidel method. See here, 83 is greater than 11 plus 4. Here 52 is greater than 3 plus 17. And 29 is greater than 3 plus 8. It is diagonally dominant. This system is also diagonally dominant. How? Here this 28 is greater than 4 plus 1. In the second equation, the coefficient of z is largest. Whereas in the third equation, this coefficient of y is the largest than the sum of other two. Absolute value, of course. So this should be rewritten as, this is equation 1, this is equation 2, and this is equation 3. Rewriting to 28x plus 4y minus z equal to 32, 2x plus 17y plus 4z equal to 35, and x plus 3y plus 10z equal to 24. This is rewritten like this. Equation 2 afterwards third, and third as equation 2. Now this system is diagonally dominant. Coefficient of x, mod of course, is greater than sum of the coefficients of y and z. Coefficient of y now is greater than sum of the coefficient of x and z. And coefficient of z is greater than sum of the coefficients of x and y. So such examples are asked. We don't evaluate the value of y from this 1 by 3 times, but 1 by 17 times. So this is a tricky example as far as the solution is concerned. So don't go directly. Make it first diagonally dominant and then solve as our usual, perhaps the simplest procedure of solving this. So do this both the problems and show me in the next lecture. I shall ask the solution for this. Okay. Thank you very much.